I need everybody to go ahead and get out 2 highlighters for me, please. And I need you to open up to your table of contents. In your table of contents, I need you to end systems of equations. And the next topic that I need you to write in your table of contents is we're going to write system of inequalities. System of inequalities. So go ahead and pause this video until everybody is on the right page, that you have this note sheet sitting in front of you. You have 2 highlighters on your desk, and your table of contents has ended systems of equations and now has systems of inequalities on it. So we're going to go ahead and highlight our title. Let me make that a little bit bigger. We have spent this whole time doing everything with an equation, but everything we can do with an equation, we can also do with an inequality. So let's look at this first question. It says, what is the main difference between an equation and an inequality? What's the biggest difference between an equation and an inequality? Well, an equation has an equal sign. So equation have an equal sign. Where an inequality, that has a less than, a greater than, a less than or equal to, or a greater than or equal to sign. So that's the biggest difference. An equation has an equal sign, and inequality has one of these 4 main symbols. So remember one of these 4 main symbols that determines a possible range of solutions. So an equation gives you one answer. When I write an answer x equals 6, the only value x can be is 6. If I write x equals 6, x can only ever potentially be 6. What if I write x is less than 6? Does that mean x can be 6? Well, no, because 6 is not less than 6. But what this tells me is that x can be anything that's below 6. So it can be 5, it can be 4, it can be 3, it can be -7, it can be negative a bajillion. So notice here on this next part, it says an equation gives me an exact solution, where an inequality gives me a range of many solutions. So how many solutions does an inequality give me? Well, it gives me an infinite number of solutions. An equation gives you one solution, where an inequality gives you an infinite number of solutions. So let's look at this first problem. It says, which of the following are solutions to the following linear function? I want you all to ignore that for right now. I want you to look at this equation right here. Y equals 2x minus 3. Can I graph that? Well, I hope I can. So if I were to graph this, what would m equal? 2 over 1. What would b equal? -3. So I'm going to plot -3. And then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And I'm then going to very nicely connect my dots. Hopefully everybody's okay with that. So now I want to know which one of these ordered pairs is a solution. So I'm going to highlight this first one, -2, 6. And I'm going to go plot -2, 6 on my coordinate plane. It's like up here, right? Is this blue dot that I just plot, is this a solution to this line? No, because this blue dot is not on my line. So I would say no. So now I'm going to look at the next one. 0, -3. Plot that. 0, -3. That's right there. Would that be considered a solution? Yes. How come? It's on my line. So go ahead and pause this video and to try the next 2. So you should have done 3, 3. Is 3, 3 a solution? You betcha. It's on my line. And my last one is 0, -6, which is down here. Is that on my line? No. So that one is not a solution. All right. So let's take a look at this next problem. It says if you graph an equation, what do you notice about those points? So when I'm graphing it, what do I notice about those points? Well, the points must be on the line. The points must be on the line. Now, what if I didn't give you what if I did not give you this coordinate plane? How would I know if this ordered pair is a solution to this? Well, all I would do is I would plug -2, 6 into that equation and would see if my left side would equal my right side. So if I take a look at this next example, notice I graphed this inequality. So notice this inequality. It says, which of the following solutions are given to the inequality? Y is less than or equal to 2x minus 3. So if you look at this picture, how does this picture look different than the picture up here? Notice this picture up here, they graphed the exact same line. 2x minus 3, 2x minus 3. They all graphed the exact same line. But what's different? Notice in an inequality picture, I have this part that's shaded in. Because this part that's shaded in represents all possible solutions. So up here above on this problem, in order for one of these ordered pairs to be a solution, it had to be on this line. With an inequality, when you graph an inequality, in order for one of these ordered pairs to be a solution, it has to either be on the line or it has to be in the shaded area. So let's take a look. If I highlight my first one, -2, 6, that's up here. Is that in my shaded area or on my line? No. So now let's do 0, -3. Is that in my shaded area or on my line? Yes. Let's do the next one. 3, 3. Is that in my shaded area or on my line? Yes. And if I do the last one, 0, -6, that's going to be down here. Now notice in this picture my shaded area stops, but in reality my line goes on forever, correct? And if my line goes on forever, my shaded area goes on forever. It goes all the way forever on this side of my line. So is this blue dot in my shaded area? Yes. So notice with an inequality, 0, -6 is a solution. But when I had an equation, 0, -6, it was not a solution. So graphing inequalities is a little bit different. So what do you notice about graphing an inequality versus graphing an equation? With an inequality, I have to shade. So with an inequality, I have to shade. So here's obviously the big question. Well, how do I graph it? How do I know to shade on this side versus this side? So go ahead and flip your paper and let's take a look at it. We have a goal, so go ahead and highlight your goal for me, please. My goal is to graph and shade an inequality. And I'm going to say actually a linear inequality. So the way you graph a line is the exact same. Quality. The only thing that's different are these two bullets down here. These two bullets down here are the only things that are different about an inequality. So we have what's called a special condition, just like open dots and closed dots. So remember when we were graphing inequalities and we had to graph it on a number line, and if this was 3, I'd have to either do an open dot or I'd have to do a closed dot, and then it would go in whatever direction? Well, I have a similar condition with this. If I have a less than or a greater than sign, I'm going to make a dotted line. If I have less than or equal to or greater than or equal to, I'm going to make a a solid line. So if my symbol would be a closed dot, then it's going to be a solid line. If it'd be an open dot, it's going to be a dotted line. And with an inequality, we also need to know when we're supposed to shade. So an inequality cuts your graph, and it cuts your graph into two pieces. You can either graph on the front or you can graph on the back. So with an inequality, how do I know when to shade? If it's less than or equal to, you're going to shade below the line. If my inequality is greater than or equal to, I'm going to shade above the line. So if I can either shade above the line or I can shade below the line. If I shade below, it's because my inequality is less than or equal to. If my inequality is greater than or equal to, I'm going to shade above the line. And I'm going to show you all how to do this, so don't stress out. So we're going to take a look at my first example. I'm going to pretend this inequality is not here, and I'm going to graph this just like I would do before. How do I graph a line? Well, I got to find M, I got to find B. So what's M in this problem? It's negative 2 over 3. What's B in this problem? It's 2. So what do I plot first, M or B? Well, I plot B first at 2. So from here, I go down 2 and I go to the right 3. And then I go down 2, I can't go to the right 3 anymore, so I'm not going to go back to my original point. I'm going to go up 2 and I'm going to go to the left 3. And then I'm going to connect my dots. Everybody's with me? Now notice, I just messed up because now I have to look at my inequality symbol. If I highlight my inequality symbol, notice is my inequality symbol less than or equal to? It's less than. So because my inequality symbol is less than, I have to make a dotted line. So I now have to go back and fix my graph, which I don't know where my eraser is. Hold on, let's see. Here, and I have to make this a dotted line, and it's not going to let me make a dotted line, so I'm just going to make my marker thicker. So I'm going to make this a dotted line. So how I make a dotted line, I just draw dashed lines like so. That's the first part. Second piece, I have to know when to shade. So notice it's a less than sign. So is that going to mean I'm shading above or I'm shading below? Well, it's less than, so I'm going to shade below. So I'm going to take my line, and notice my line right here cuts my picture into two places. I can either shade on this part of my line or I can shade on this part of my line because it cuts it. I can't ever shade on both sides of my line. I can either shade over here or I can shade over here. Because it's less than, I'm going to shade below that line. And how I represent below is I want you to pick a point, any point on your line. So I'm going to pick this point, and I want you to draw a down arrow because that's what below means, below. Notice I'm drawing a down arrow, not a slanted arrow. Because I drew this down arrow right here, that tells me I'm shading on this side of my equation. So I get to scribble all on my paper today. Hooray! You didn't know you were coloring today in math class. So I shaded on that side of my line because it was a less than sign, and less than meant I'm shading below. So I drew a down arrow from my line, and that told me where it was below. So the purpose of shading is so I know all my possible solutions. But notice on this picture I have a dotted line. So if I plotted a point on my dotted line, would that be considered a solution? No, because that's like saying 2 is less than 2, which is not a true statement. Let's go ahead and look at another one. Let's go down and look at number 2. I lied. We're going to skip 2 for right now. We're going to go to 3 first. Let's go to 3 first, just because it's quicker. So number 2, first thing I got to do is graph it. M equals 1 over 1, b equals -4. So go to -4, go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, all the way across my grid. Connect my dots. So notice you have two choices. My line is cutting my coordinate plane right here. So I can either shade on this side of my line, or I can shade on all of this side of my line. One thing I gotta make sure is notice that this line is a solid line. Is that okay that it's a solid line? Yes, because of my inequality symbol, it's greater than or equal to. So because my inequality symbol is greater than or equal to, since it's greater than, does that mean I'm going to shade above my line or below my line? That means I'm going to shade above my line. So I'm going to pick a point anywhere on my line, right here, and I'm going to draw an up arrow. Notice my arrow's going up, it's not going slanting. I drew an up arrow because this symbol is greater than. So because this up arrow is on this side of my line, I'm going to shade all on that side. So the shading represents all possible solutions. So let's do number 2 now. Looking at number 2, can I immediately graph it? No. Why not? Well, y is not by itself. So I got to get y by itself. So how do I get y by itself? I'm going to subtract 2x first. So I have -3y is less than or equal to -2x plus 6. So now what am I going to do? I'm going to divide by -3. Hey, what happens when I divide by a negative? My sign flips. So y is greater than or equal to 2x over 3 minus 2. So because my sign flipped, I'm looking at this sign to help me get my answer. You always look at the sign when y is by itself. So hopefully I'm okay to graph this. So I'm going to graph -2, and I'm going to go up 2 over 3, and then down 2 and to the left 3. I'm going to connect my dots. It's a solid line because this symbol is greater than or equal to. So now I have two options. This line cuts my coordinate plane. I can either shade here or I can shade up here. Because this symbol is greater than or equal to, I'm going to draw an up arrow on any point. It doesn't matter which point. Pick a point, draw an up arrow. If I picked a different point, I picked this one, drew an up arrow, guess what? That's on the same side. This is on the same side. This is on the same side. So it tells me I'm shading on this side of my line. Notice my shading never cuts through my line. My shading only ever is on one side. So I want you to go ahead and pause this video, and I want you to try the next 3 problems on your own, and then unpause this video and we'll go over it together. So if we take a look at number 4, can I immediately graph it? No. Why not? Y is not by itself, so I got to add 8x to both sides. Hopefully you're so good at this you can do it in your sleep now. I'm now going to divide by 2 on everybody. So y is greater than 4x plus 6. I now use this equation to give me everything else. So I'm going to graph 6, and yes, it goes off my grid, but I'll be alright. And then I can't go up and to the right, so I'm going to go down and to the left. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And I'm going to connect my dots. But be careful. Looking at my inequality symbol, am I going to draw a solid line or a dotted line? I'm going to draw a solid line. No, I lied. I'm drawing a dotted line because it's greater than. So because this cuts it, notice here, I can either shade it on this side or I can shade it on this side. So greater than means I'm shading up. So pick any point you want, draw an up arrow. That tells me I'm shading on this side. Can somebody tell me the point of shading? What is the purpose of shading? The purpose of shading is to represent all possible solutions. So the next one, it's a special type of line. It's a Hoy line. So I'm going to plot it at 3. And am I going to draw a dotted line or a solid line? Well, I got to look at my inequality symbol. I'm going to draw a dotted line. And because it's less than, does that mean I'm shading above or below? Well, I'm shading below, so I'm going to draw a down arrow. And that tells me I shade over here. And if I do the last one, this is a funny type of line. It's a Vux line. So I'm going to plot it at -1. I'm now going to look at my inequality symbol. Am I going to draw a dotted line or a solid line? A solid line. Looking at my solid line, looking at my inequality symbol, I notice that it's greater. So I can't shade above because if I draw an up arrow, notice that's just my line, and that's not going to help me. When I shade, I can either shade on this side or I can shade on this side. So which one of these has greater numbers in respect to the x-axis? Well, greater than and the x-axis would be over here. So I'm going to shade on this side of my line. So hopefully you're all doing okay because you're getting ready to practice some more problems.